Good morning, everybody, or good afternoon, good evening, okay, depending on where you are. Welcome to Easy Learn with the Samuel again. Today we will proceed and we'll be solving some questions on the refraction of light. Okay, we'll be solving some questions on that, and actually, I think we just have to solve a few questions. Okay, I used to say you cannot solve all questions in pieces. That's not possible. Okay, but you need to go through some questions so that you can have an idea of what you'll be dealing with when you are working on your own. So because of that, let's I have some questions that are prepared here. Okay. Okay. Okay, this is a form. This question was prepared by the former, so it's an assignment actually. So now the first question here, let's start from number two. I see that number one is equal to name. Let's start from number two. The question says that a coin placed below a rectangular glass block of thickness 9 centimeter, thickness 9 centimeter, and refractive index 1.5 is viewed vertically above the block. Find the apparent displacement of the coin. A coin placed below a rectangular glass block of thickness 9 centimeter and refractive index 1.5 is viewed vertically above the block. Find the apparent displacement of the coin. Like I used to say, the first thing you have to do when you are solving questions in physics is to first of all note your parameters, and we'll be doing that. We were given our thickness to be 9 centimeter, and we were given refractive index to be 1.5. Okay, look at it here, refractive index is what? 1.5. Those are the two things we were being given. Okay, so let's quickly go into that. Sorry. Question one. I love to love. Okay. Let's do this. Okay. Question one. Let's say we're given thickness. Sorry, please. Oh, sorry for that. We're given the thickness to be equal to 9 centimeter. Then we have our refractive index to be equal to 1.5. Remember, I told you that the thickness is equal to your read depth. Okay, the thickness is equal to your read depth. So the question says that we should find what? It says that we should uh, find the apparent displacement. Apparent displacement. That's what the question is asking for. Let's quickly do that. Now, we know that to find our apparent displacement, which we said is equal to rate, if you can recall, we said equals to read depth minus apparent depth. Okay? And we know that the relationship between the apparent depth, the read depth, and the refractive index is this. This is the relationship between them, and which is the refractive index equal to read depth all over apparent depth. Remember, I told you that your apparent depth is equal, your read depth is equal to your what? Your thickness, which means this equals to 9 over apparent displacement. So our apparent displacement will be equal to 9 over 1.5. Okay? And this will give you 6. This equals to 6 centimeter, which means our apparent displacement is equal to 6 centimeter. Then let's now go into this. This is the main formula to get our apparent displacement. Our apparent depth is 6 centimeter. Now let's find our apparent displacement. Apparent displacement equals to real depth minus apparent depth, which is equal to 9 centimeter minus 6 centimeter. Then we know that our apparent displacement will be equal to what? 3 centimeter. And that's the first answer for that. Let's look at the second question. This is that a trough 12 centimeter deep is filled with water of refractive index 4/3. By how much would a coin at the bottom of the trough appear to be displayed when viewed vertically from above the water surface? Now, looking at what we have here, what are the parameters given? We were given this, a trough 12 centimeter deep. That is how deep the trough is. That is the real depth. And we also given the what? Refractive index to be equal to 4/3. So we are being asked to find the displacement again. Say, by how much, look at it, by how much would a coin at the bottom of the trough appear to be displaced? To be displaced when viewed vertically from above the water. Okay, let's go. Now, let's do this. And this is number 2. What are the parameters given? We were given the what? The real depth. We were given the what? The real depth to be equal to 12 centimeter and the refractive index to be equal to 4/3. I think that's it, right? Yes, 12 centimeter. So let's solve. Remember, our displacement will still remain as what? Real depth minus apparent depth. And we know that refractive index is equal to real depth over apparent depth. Sorry for this. Equals to real depth over apparent depth, which is equal to what? 12 over apparent depth. And this will be 4/3 equals to 12 over apparent depth. This simply means for apparent depth will be equal to what? 3 times 12. And that means our apparent depth will definitely be equal to what? 36/4. Now, 36/4 will give you 9 centimeter. That is our apparent depth. Now, our apparent displacement or lateral displacement or vertical displacement, because the question that if it is being viewed vertically from above, which is also A, equal to real depth, like you now know, minus your apparent depth. We did this in the previous note. So, and this equals to what? What's the real depth? 12, and the apparent depth is what? 9. Everything in centimeter, and that will definitely give you 3.0 0 centimeter. And that's that about that too. Very simple, right? Let's move on. Sorry. Sorry for that, please. Look at the fourth question. The fourth question says a coin placed at bottom of a cube of glass T cm thick. Now that T centimeter, the T centimeter represents the thickness, which is the what? The real depth. Remember, I told you that thickness of a glass is equal to the what? To the real depth. We did that in the previous class. If the refractive index, sorry, do something about that. Sorry. If the refractive index, okay, if the refractive index of glass is n, we are given the refractive index to be represented by n. How high does the coin appear to be raised to an observer looking perpendicularly into the glass? Now they said we should show our workings, and we have been given a series of options. You have option A, option B, option C, option D, and option E. 4 options. Okay, let's solve. Number 3, as usual. Okay. Now, that question says that you have a thickness of T centimeter. In a nutshell, I'll just write our real depth now. Real depth equals to T centimeter, sorry. T centimeter, our refractive index equals to, in fact, n equals to n, okay. Refractive index equals to n, okay. Now we are being asked to find how, look at the question again, so that I want you to understand what they said. The question says, how high does the coin appear to be raised? How high? I would like to show you something here. How high? Now, for this, we are going to have a little explanation, and I would like to give you a demonstration of what we are doing with here. How high? Okay, this is it. This is the coin. This is the coin here. Sorry. We have our coin here. Okay, and you know that when you have a coin in the water, it will definitely, let's say, in this direction, because it's being viewed perpendicularly. Okay, let's just do this. So since it's being viewed perpendicularly, let me group on this and adjust it a bit. Okay, we all know that, let's say this is indicated, it bends a bit. Okay, because normally your there will be refraction and it bends away from the normal. Now, listen carefully. When this object is here, it's being viewed. Let's say it's being viewed by someone here. Okay. The truth is that this object will actually not be showing as if it is here any longer. We have apparent depth. Okay. The object will not be showing as if it's here. You all know that, the object the observer will be seeing the object, let's say somewhere around here. Okay. Now, from here, this height is the apparent depth, while from here downward is the real depth. Sorry for that again. From this distance is the apparent depth, while this distance is the real depth. Now the difference between this and this, which is this, there's a difference between this and there's a difference between this. That difference is what we are being asked to calculate. Let us say this. Let's call this. Now this will be the displacement. Displacement. Let's call it displacement. It is this displacement that you are being asked to calculate. It is this displacement you are being asked to calculate according to what? According to the question here. You say to observe how high does the coin appear to be raised? How high does the coin appear to be raised? That's displacement. Okay, you know the coin moved from here to these points. So how high? How high? How high? And that is our what? Our lateral displacement, or you can call it vertical displacement. And we all know that vertical displacement is equal to what? A equals to real depth minus apparent depth. And we know that we cannot find our apparent displacement without knowing our what? Our apparent depth. Our apparent depth, like we have done in all the previous ones, equal to what? Real depth over refractive index, which is equal to, what's our refractive index? T over n. So our lateral displacement will be equal to real depth minus apparent depth. And our lateral displacement will definitely be equal to, what's our real depth? T minus apparent depth, which is what? T over n. Then this will be n over n, this is over 1. I'm sure you know that. So 1 in n, that's n. N times t. N t. N in n, that is 1. 1 times t. T. Then with your mathematical knowledge, you can factorize. Then this will be t to the bracket of what? N minus 1 over n. You can go further to say your t. You can say that a equals to t into bracket of 1 minus 1 over n. You are still writing the same thing. So let me just do something here. So oh my god. Oh. I just want, okay, let me just clean this. Let me bring it down a bit. Okay, so this bar, this is n. So I can say our a equals to t into bracket of n over n minus 1 over n. And this will give me t to be in the bracket of 1 minus 1 over n. So these are apparent displacement. So either you write, you stop, okay, either you have your answer as this or this. Okay, let's check the option. What do we have as our option there? Okay, you see, this is the right answer. T into bracket of, okay, no. This is it. This is the option. T into bracket of n minus 1, bracket close everything over n, which means they stopped here. Okay, they stopped here. Okay, so this is the answer. And that's that for number 3. Let's go for number 4. Let's go for number 4. Number 5 rather. No, it's 4 here. The speed of light in air is this. We all know this. I did this with us. Sorry, I did this with us in the during the notes. I told us the speed of light for each of these. For each of this medium, medium, okay, medium, yes, medium, each of this medium. And I told us that for light is 3 times 10 to the power 8 meter per second. That is air. Rather, speed of light in air, 3 times 10 to the power 8 meter per second. For speed of light in glass is what? It is 2 times 10 to the power 8 meter per second. And then the speed of light in water is 2.25 times 10 to the power 8 meter per second. So now this question is not asking us to do what? This question is asking us to, okay, they said the speed of light in air is this, 3 times 10 to the power 8 meter per second. If the refractive index of light from air to water is this, 4/3. Okay, that's the refractive index of light from air to water. What is the speed of light in water? Now, let's solve. Before you even start, you should know what your answer will be. Okay, I'm sure you know that your answer should be 2.25 times 10 to the power 8 meter per second. But let's work it out. For given, we are given the speed of light in air to be equal to 3 times 10 to the power 8 meter per second, and you're given the refractive index to be equal to what? 4/3. And you're going to have to calculate the speed of light in water. Okay, so solution. Let me quickly refresh our memory. Remember I gave you so many formulas. I said speed of refractive index can be equal to wavelength in medium 1, or let's say wavelength, okay, let's say medium 1 over wavelength in medium 2, or it can be sine I over sine R. It can also be equal to what? Speed in medium 1 over speed in medium 2. Now looking at these three formulas, which one do you think that you can use? Definitely, we don't have wavelength, which means this formula can be used. We don't have wavelength. We don't have angle at all, so we cannot use this sine. This one is cancelled. We cannot use it. Look at this. We have speed in a medium. We have two media anyway. In this question, we are given air and water. Now this air will be what? Medium 1. Water will be medium 2. Because according to this question, the question says that what? The question says that the speed of light in air is this if the refractive index of light from air to water, okay, from air to water, which means that it's moving from air to water. And you know that the first medium will be the air, and the second medium will be the what? Will be the water. So we can use this formula because we have our speed in air and we have our refractive index of what? Of refractive index of air to water. So we can use this formula. Okay, so let's solve. Let us say, let me write it. Using n equals to v1 over v2, which is like we're saying refractive index of air to water equals to what? Speed in air over speed in water. Then this should be what? 4/3. 4/3 equal to 3 times 10 to the power 8 all over speed in water, which is unknown. And this will be 4 speed in water over 3 times 10 to the power 8. Definitely this will be 4 speed in water to be equal to 9 times 10 to the power 8. And then you have this speed in water to be equal to 9 times 10 to the power 8 all over 4. Now with that, you have the answer as this. 2, sorry, 225. With this, it can be written as instead form as 2 point. It can be written as 2.25 it can be written as 2.25 times 10 to the power 8. If you don't believe me, look at this. You know, your point is around this point. Okay, this is where you have your point. Then I can bring it from here to say 1, 2, 3, 4, 5, 6, 7, 8. I'm sure you all understand what I did there. You were taught all these things in your junior class. Okay, so that's not about that. Let's move on to the next question. And for the next question, it says light of wavelength 5,000 times 10 to the power minus 8 travels in free space with a velocity of what? 3.8 times 10 to the power 3.0 times 10 to the power 8 rather meter per second. What is its wavelength? What is its wavelength in glass of refractive index? Now, what we have to calculate is wavelength of this speed, wavelength of this light in glass. We have the wavelength in air, that is the free space. Now we are being asked to calculate the wavelength. What's the wavelength in glass of refractive index 1.5? In glass of refractive index 1.5. Remember, the first thing to do is to what? To note the parameters. Okay, so let's go. Question 5. Given, we have wavelength in air to be equal to 5,000 10 to the power minus 8. And we also have what? Refractive index of glass. That is refractive index of glass with respect to air to be equal to what? 1.5, right? Yeah, 1.5. Then we are being asked to find the refractive index. Oh, Jesus. We are being asked to find the wavelength rather. We are being asked to find the wavelength in glass. Okay, let's take a step back. Look at these formulas I gave you here the other time. This is the first one, the second one, and the third one. You can see that this is the one with wavelength. So this is the suitable formula. Okay, look at the question again. You have this to be speed of what? Wavelength of 5,000 times 10 to the power minus 8 travels in free space of velocity of what? Of this. Okay, what is its wavelength? Okay, you are even being given the velocity. You are being given the velocity, but don't let the velocity deceive you. If you should put your velocity here, velocity in what? In air to be equal to 3 times 10 to the power 8 meter per second. It has something to do here. It has something to do. Seriously, it has something to do. Because you cannot use this form, you cannot use your speed in air without knowing your speed in glass. And even after that, for you to get your wavelength, the difference between, okay, let me just say, you have this speed in of light equals to frequency times wavelength. So you must know the frequency before you can even have the wavelength. So it's not just the best one to be used. So let's move on. Okay, so let's use so using the particle index of glass with respect to air will be equal to wavelength in air over wavelength in glass, and that is 1.5 to be equal to what's wavelength in air? 5,000 times 10 to the power minus 8 over the particle index of glass, which is unknown, and that will be definitely be wavelength in glass equal to minus 8 divided by 1.5. Now, if you point that on your calculator, you're going to have something of this 3.3. Jesus. Sorry, please. Sorry for that technical glitch again. 33 times 10 to the power minus 5. Mind you, you are going to be having a recurring decimal here, so that's why I just I left it like that, which can be automatically written as 3333 times 10 to the power minus 8. Now somebody will be wondering, how did you get this? From here, you have your decimal here, right? That's the decimal point. Now we want to move it backward. I can say 1, 2, 3. So which means it will now become this 3, 3, 3, 3 points will be at the back here. But remember that is raised by minus 3 extra. So minus 3 minus 5 minus 3, that will give you minus 8. So, and that's the answer for this. Okay, we are done with those questions, but I also have one more question I would like to give to you. Okay, hold on. Now, everybody, let's look at this question. I just have to quickly type that one in order to waste our time. Okay. Let me see. Let me adjust this a bit. Okay. Now the question says two rays of light. Okay, two rays of light from a point below the surface of water are equally inclined to the vertical and are inclined to each other at 60 degrees in water. What is the angle between the rays when okay, we're back. What's the angle between the rays when they emerge into air? Take refractive index of water to be 4/3. Okay, let's quickly solve that. And as usual, when we want to do this, the first thing we do is to find the given parameters. Okay, so let's say solution, then given. We are given angle. Okay, let's say angle of 60 degrees. Let us see angle. I will explain that angle is equal to 60 degrees. And refractive index to be equal to 4/3. I have a bit of extension to do here. Okay, now let's first of all understand what this question is saying. Okay, according to that question, you have two rays. Okay, two rays of light emerging from what? two rays of light emerging from a point below the surface of water. Let us assume that they are emerging from this point. Sorry. They are emerging from this point, the two rays, and let's say the rays are A, and A and B. And the question says further that they are equally inclined to the what? To the vertical. Okay, let me take my vertical from here like this. Okay, that means that we have to adjust. Make a few adjustments on this. I have to make it look okay. Because question that they are equally inclined. Let's see. Equally inclined. I have to. Okay. Okay. Equally inclined. Okay, let's believe that they are equally inclined. Okay. And you know that when they are about to eject right at this point, when they are entering into the air, what we have here is water. Okay, I'm just using that as an example. Okay, I'm using that glass as an example. So what we have here is what? This is the water and this is the air. Okay, the free space. So when the ray I imagine into the air, you know they will what? They will deviate away from the what? From the normal. Okay, so let's say this deviates like this, and this deviates like this. Okay, let me quickly. Okay, let me draw another normal that will pass through. Okay, good. Okay, now let me do the next thing. You can see the concept is that what the rays from a point below the surface of water are equally inclined. Two rays equally inclined to the what? To the vertical, and are inclined to each other at an angle 60 degrees. It means that everything right here is what? 60 degrees. And since they are equal, since they are equally inclined, I can say that each of them will be 30. Sorry. Let me write it down outside there. 30 degree each, and I'll just okay. So 30 degree, and this one too will be what? This one too will be 30 degrees, because they are equally what? They are equally inclined, but altogether it's what? 60 degrees. 60 degrees, but since they are equally inclined, this will be 30, this will be 30. Now, this will be, we also have another angle here, Class, listen to me very carefully. I will quickly explain something. Remember, when we have a particle index of glass, sorry, we are dealing with water. Water here. That is, this means that the light ray is moving from water and entering to here. That is, it comes like this, from water, from air. Sorry, moving from air and entering into the water. Okay, moving from air entering into the water. Then this will be equal to what? This will be equal to sine I over sine R. But in the case that we are having on the board here, what happens is that the light ray is moving from water to air. From water entering air. Which means what we will be experiencing will be refractive index, refractive index, refractive index of water to air will now be equal to what? Inverse. Sine R over sine I. Remember, I told you something when we were dealing with critical angle. Our critical angle, we have it to be refraction index equals what? 1 over sine of critical angle. But remember that this one is due to the fact that we have this to be sine 90 over sine C. Because I said something. Before you can have a critical angle, remember what I told you then. I'll quickly explain, then I will go back so that I can refresh your memory. Before you can have your critical angle, you have some conditions that must be fulfilled. Number one, the light ray must be moving from denser medium into less dense medium. From denser medium into less dense medium. Remember, denser medium are medium that, or let me say media, or any medium that has less speed of light when you compare it to another medium. For example, water here is a is a denser medium compared to air. Air has a speed of light of what? 3 times 10 to the power 8. But water has a speed of light of what? 2.25 times 10 to the power 8. Okay? Which means that what? They are different. Now, this is 2.25, lesser than what? 3.38. This is denser. Now, which means the first